Now we will learn how to write the main VHDL model MVM and test bench VHDL model TVM for 16:1 multiplexer using 4:1 multiplexer as a component. And we are going to use these two figures as the reference. So mux 16_1 is our top level entity or the parent entity, and it takes 16 inputs named as I161 and 4 select lines named as S161, and its output is Y161. And the component for this parent entity is a 4:1 multiplexer which is named as MUX41. It takes 4 inputs I41, 2 select lines S41, and the output is Y41. And we follow this particular nomenclature that uh, we write the input and output signals for the component inside the block and not outside, unlike the parent entity. And this diagram, which is going to help us write the MVM for parent entities as follows. We have expressed the 16:1 multiplexer as a combination of 5 4:1 multiplexers, which means we are having 5 instances of 4:1 multiplexer. Names are mux41_1, mux41_2, mux41_3, mux41_4, and mux41_5. The 16 inputs of 16:1 multiplexer are divided as first 4 to the first instance, that is I161 parenthesis 0 to I161 parenthesis 3. The next 4, that is I161 4 to I161 7 to the second instance, I161 8 to 11 to the third instance, and I161 12 to 15 to the fourth instance of the component. This 4 instances of 4:1 multiplexer form the level 1 of implementation, and all these 4 instances receive the select lines S161 parenthesis 0 comma S161 parenthesis 0, sorry, S161 parenthesis 1 and S161 parenthesis 0. Now we come to the second stage of implementation, the fifth instance of 4:1 multiplexer mux41_5. It accepts the individual outputs of the previous 4 instances, and it accepts two select lines, that is S161 parenthesis 3 comma S161 parenthesis 2. P, Q, R and S are the intermediate signals which connect the output of the first 4 instances of 4:1 multiplexer to the 4 inputs of the fifth instance, and the output of the fifth instance of 4:1 multiplexer, it forms the output Y161 of the 16:1 multiplexer. Now we will use this two block diagrams and this block diagram for writing the MVM for 16:1 multiplexer using 4:1 multiplexer as a component. Now we move on to Xilinx ISC. File, new project. We will use the name mux 16_1. This is our top level entity or parent entity. Control A, Control C, next, next, finish. Keep the tool in implementation mode. Target line, right click, new source, VHDL module, paste it, reselect, next, change the architecture name to entity name underscore arch. Now we'll start giving this inputs I161, S161 and Y161. So I161, it's a bus. It goes from 15 to 0, 15 down to 0. S161, 3 down to 0. And we have Y161 output. Next, finish. Delete all the comments. Now, as we have seen in the tutorial for full adder using half adder, we will execute 4 steps which are characteristic to structural modeling style. That is component creation, defining intermediate signals, then component instantiation and port mapping. Component creation and defining intermediate signals is done in the declaration section of architecture body of the parent entity or top level entity, while component instantiation and port mapping is done in the logic section of the architecture body of MVM of top level entity. So we will create the component here. As we know, the name of our component is MUX41 and it has the inputs I41, select lines S41 and output is Y41. So component name is port in parenthesis I41 space colon space mode std underscore logic underscore vector 3 down to 0 S41 input std underscore logic underscore vector 1 down to 0. Output is Y41 out std underscore logic. Being the last signal, not put a semicolon, closing parenthesis semicolon, we can say end component. Okay, now we will define the intermediate signals PQRNS using the syntax for component declaration using the syntax for signal declaration, signal space P Q R S space colon data type. So having done this, we have completed 2 steps of structural modeling style, that is component creation and defining intermediate signals. Now we start doing the component instantiation and port mapping. As we see here, we have to create 5 instances, mux41 underscore 1 to mux41 underscore 5, and the signals are the way they are. Okay, so mux41 underscore 1 space colon space component name port space map. Five instance, change the instance names underscore 2 underscore 3 underscore 4 underscore 5. and here my reference is the four inputs of multiplexer. Select lines S41 parenthesis 1, S41 parenthesis 0, and output Y41. This has to be the order. So as per this block diagram, we can see that the first four inputs of 16:1 are mapped and the select lines are mapped. So we will write I161 parenthesis 0 comma or we can try to write parenthesis 1 parenthesis 2 parenthesis 3 S161 parenthesis 1 comma S161 parenthesis 0 and P. So the first four instances are receiving the select lines parenthesis 1 and 0. So we'll write 0, 1, 2, 3, 4, 5, 6, 7, and output is Q. 8, 9, 10, 11, 12, 13, 14, 15, output is R, output is S. For the last instance, it is P, Q, R, S, S161 3, S161 2, and Y161. S161 3, 2, output is Y, 161. We have to make some changes here. 161, it's 0 to 15, and here 1, 2, 3, 4, 5, 6, 7. So we'll try to resolve these problems in this way. So we have to write here 0 to 3, and we have to delete this. And 1 down to 0, delete this. 4 to 7, 1 down to 0, 8 to 11, 0 to 3, 1 down to 0, 4 to 7, 1 down to 0, 8 to 11, 1 down to 0, 12 to 15, 1 down to 0, and last We will have to define one vector here, and we have to map the vector to our originally defined signals. So we can have signal temp colon std underscore logic underscore vector down to 0. We can have 0 to 3. So signal P is a vector 0 to 3. Now we have completed the MVM for parent entity. I'll write it for the component. Entity marks 41 is I41, S41, and Y41. architecture mux 41 underscore arch of mux 41 is begin. Parenthesis I41 S41 if S41 equal to double quotes 00 Y41 is assigned I41 parenthesis 0. Else if S41 is equal to 0 1 and Y41 gets I41 1 1 0 2 in process. And errors. Zero to 3 1 down to 0. Thus we have successfully completed the synthesis of MVM, that is without um, errors and warnings. Over to simulation. Change the tool from implementation to simulation mode. Right click, new source, test bench, underscore TB, reselect, next, finish. Delete the comments, delete the clock period statement, delete the clock generation processes, We can initialize the inputs to x double quotes a, select lines to 1, S161. S161 is assigned S161 plus 1. Wait for 10 nanoseconds. We can add one library statement and send dot all. Float. So you can see here when select lines change from 4 zeros to 4 ones in 160 nanoseconds. We can see here that the input given is hexadecimal AAAA, and we can see here that as when select lines change from 0000 to 1111, then we are getting outputs accordingly. Thank you very much.